Hi everyone, this lesson is on law of sines, and we use law of the sines for solving oblique triangles. So mostly we're going to use law of sines for triangles that have two angles and one side, and sometimes we're going to use it for triangles that have two sides and one angle that is not in between. So let's get started and see how we do. What I want to do is just review with you for about a minute the proof of the law of the sines, and the proof comes from basically two sine formulas basically in the same problem, whereas if you put yourself at one angle, let's say angle C, and you found the sine of angle C. Sine is opposite over hypotenuse, so that would be h over a, and then you moved yourself to the other end of the triangle and you said, well, you have sine of angle A is also the opposite side, which is h, over the hypotenuse, which is c. And if I were to take those two trig functions, which is sine of c is h over a and sine of a is h over c, and I solve for h, meaning I cross multiplied, I'd get h is equal to a times sine of angle c, and I would get h is equal to c times sine of angle a. And in doing that, because h's are equal to each other, because they both are the same height, I would set the two equations equal to each other. I'd have a times sine of angle c equals c times sine of angle a. And I would basically try to get my coefficients down below and remove them from the front. So I would divide out the a, I would divide out c, and in doing so, these cancel, c's are going to cancel, those make 1, that makes 1, and I end up getting sine of angle c over little c is equal to sine of angle a over little a. And what this is basically the formula for using the law of the sines. And that we are missing the sine of angle b over little b, but we're going to use this formula to solve an oblique triangle. And so basically, these are the two instances when I would most of the time use law of the sines. Two angles and one side, or the angles surrounding the side, meaning if I have two triangles like this, okay, so the first one, if I gave you this angle, and a side, I would use angle, angle, side. For if I had this angle, and I was given a side in between, that's angle, side, angle, and I would also use law of the sines. These are the formulas. Remember, you can only use two at a time, but they are proportions, so that's what you're going to do. Note that capital A, which is going to be our angles. Angles we always represent with capital letters, and the little letters are the sides. And so like if angle A is here, then little a would be opposite that angle. And if I have angle B, then little b would be opposite that angle, etc. There is this case right here, which is side-side angle, and we use that to solve also law of sines, but this is what we have as an ambiguous case. So it's a little bit tricky because sometimes you could have one triangle, you could have two triangles, or you could have no triangle. Which would look like something like this where they wouldn't connect. But we're going to do a couple of those examples. Just to differentiate between law of sines and law of cosines, again, we use law of sines for angle, side, angle, or side, angle, angle. We use law of cosines if we have three sides and an angle in between two sides. So we're going to start off, I'd like you to label your triangle. So I'm going to call this A, angle B, angle C. Little a is 40 degrees, and we've got B is 60 degrees, and we have little a, which is opposite angle A, and that's 4. What your job is to do is to solve for little c and little b, okay? And you're going to solve for both of those because that's what solving a triangle does. It finds all the sides and it finds all the angles. Now, given that angle A is 40 and angle B is 60, that makes 100 degrees. And we know that the sum of the angles in of a triangle is 180, which means that angle C has to be 80 degrees because that's what's left. So also to remember is that if you want to find a side, then you have to have that opposite angle. Or if you want to find that angle, you have to have that opposite side. So we're going to start off finding little side B. So you're going to say sine of angle B, which over little b, is equal to sine of angle A over little a. And so that's sort of the formula we're going to use. Putting the values in, sine of angle B is sine of 60 over little b, that's our unknown, equals sine of angle A, which is 40 degrees, over little a, which is 4. I'm going to cross multiply. I'm going to say B times sine of angle 40 is equal to 4 times sine of angle 60. And because our goal is to solve for little b, I'm going to divide both sides, and I'm going to get 4 times sine of angle 60, all divided by sine of angle 40. And I'm going to put that in parentheses because parentheses are good. And so on the side here, where my calculator is, I'm going to make sure that I'm in degrees. So make sure you're in degrees. If you're not in degrees, flip that and change the mode and put that in degrees. And you just change the mode by clicking on that, radians or degrees. So I'm going to type in sine of 60. So I'm going to go to trig first, maybe. And I'm going to go, let's see. Let's see what's happening with this. All right. I'm not sure what's going on with that, but that's okay. I'm going to use it on my calculator, and I'll try to fix that in a minute. So I'm going to type in sine of angle 60. So sine of angle 60, I get 0.8660. Always make sure you go 4 decimal places, but it's also okay just to enter the value and then continue. Very strange that this isn't working. Okay, I'm going to try this again. Here we go. Sine of 60. So I'm going to go sine of 60 point. Put that calculator away. I'm going to hit enter. By using the point right there, what that does is it ensures that it's going to be a decimal. So sine of 60, I'm going to multiply then by 4. I'm going to enter again. And lastly, I'm going to divide this value. So I'm going to hit the division symbol. And by doing that, it automatically picks up the answer that I just had done. Parenthesis, sine of 40 degrees. So sine, and I'm going to type in 40, and then hit enter. And so it looks like my answer is going to be 5.3. Let's see. We're going to round our angles to the nearest degree, and we're going to round our sides to the nearest hundredth. So that's going to be B is about 5.39. And so that's our side B. So that's now 5.39. Now to find C, I'm going to use, again, you've got to use the opposite side and that angle. So that's going to be sine of angle C over little c is equal to sine of angle A over little a. And in doing that, we're going to get sine of 80 degrees over little c is equal to sine of angle A, which we already wrote over here, which is sine of angle 40 over 4. I'm going to cross multiply c times sine of 40 degrees is equal to 4 times sine of 80 degrees. And to find c by itself, I'm going to go 4 times sine of 80 divided by sine of 40 degrees. And you absolutely can type this all in your calculator at once. I do like to do it separate, but I'm going to show you what to do that. So we would go, this is very strange. Let's see. I'm not really sure what's happening with this as far as it keeps giving me a weird thing. But anyway, let's keep trying. So I'm going to type in, I got 4, still not working. I'm just going to type it in. So we've got sine of, let's see, 80 point, I'm going to get that number, enter, times 4. check your calculator, make sure you're getting the same thing as me. I got 3.9. I'm going to divide that by sine of 40 degrees. So make sure you use parentheses. So sine of 40 and enter. So I get about 6.13. So for this value is about 6.13. And so based on that, what I have is this side, which is 6.13, and I have the other side, which is little b. So I would always put your answers in little boxes. We like that. Everything's nice. We can find your work. Make sure your work is very organized and clean. So you would put little b as approximately 5.39. You'd put little c as approximately 6.13. And the other angle that we found was the measure of angle C, which was equal to 80 degrees. And notice that gets an equal sign because we didn't round that off. For this problem, this is an angle side, but let's just verify. We've got angle B, which is 64 degrees. We have angle C, which is 38 degrees. And we have little b, which is 9. And again, not sure if this is very temperamental right now, but let's try this one more time. 64. Nope, I don't know what's going on with that, but okay. So you would take 180 degrees, because remember, you want to find angle. If you are given two angles, you have all three angles. Okay, so we have 180 subtract 38 degrees, and then subtract 64. I get 78 degrees. So this angle right here is 78 degrees. So we just found angle A. We have B, we have little b. So we're definitely going to use sine of angle B and little b to find my other two sides. I'm going to find little a first. So I'm going to set sine of angle A over little a. So I'm going to cross multiply once I plug my numbers in. So sine of angle B is sine of 64 over the opposite side, which is 9, is equal to the sine of 78 degrees over little a, which is what we're trying to find first, okay? Cross multiply, we get a times sine of 64 is equal to 9 times sine of 78 degrees. We're going to isolate the a, and so we're going to get a equals 9 times sine of angle 78, and we're going to divide that by sine of 64. And in doing that, I feel like I should try one more time. Trig? Okay, I'm not sure what's happening with this. All right. Sorry about that. Okay, so we are going to go 9 times, let's see, trig, which is sine of 78. So make sure you get the same answer. So I'm going 9 times 78. I hit enter. I get 8.803. I'm going to take that answer. I'm going to divide that by sine. So I'm going to go with my trig, sine of 64. And let's see. Enter. I get 9.79. So almost, that's it, 9.79. So A is approximately 9.79. So that's one of our solutions. And so we would put that value in here as A is 9.79. And to find little c, I'm going to use sine of angle C over little c is equal to, I'm going to use sine of b again, so sine of b over little b. I'm going to plug my numbers in, so sine of 38 over little c is equal to, let's see, I'm going to use sine of 64 over 9. And I'm going to cross multiply. C times sine of 64 equals 9 times sine of 38. So C is by itself now. I'm dividing that out. 9 times sine of 38 divided by sine of 64. And this is going to be about, sine, 38 is about 0.615. I'm going to multiply that by 9. and I'm going to take that answer and divide it by parentheses. Always use parentheses if you can. Sine of 64, and hit enter. I get about 6.16. So this is about 6.16. So just keep in mind that 6.16, that sides opposite the smallest angle should be the smallest side. So because 38 is our smallest angle, that means the side opposite that should be the smallest side. And also angle A, which was 78 degrees, should have the biggest side opposite that as well. Okay, cool. So we did both examples. There's lots more examples that you can do and you can practice for, but I would suggest that we're going to do something also now that is not law of the signs, but the still law of the signs, but not the regular case. We're going to use the ambiguous case now, which is when you see side angle. And so that's the little tricky one. So ambiguous case is side angle. And so that's what we're going to practice, okay? So for side angle, meaning they give us a side, they give us an angle, all right? Notice that the angle is not in between the two sides, because if the angle was in between the two sides, I would use law of the cosines, all right? Now, using law of the sines, I'm going to have 1, 2, or no possible triangles, okay? So you just don't know what's going to happen. So we're going to start off. You can look at this. You can go back, pause the screen, and look back. This sort of tells you the rules to why certain things are going to be side angle and why you're going to get 1, 2, or no triangles. So we're going to start off, and heads up, full no solution for this one, but let's work through this. So I want you to draw a triangle, and and just label it your ABC, and what you're going to get is you've got little a is 2, you've got little c is 1, and you've got angle C, which is 50 degrees. So we know right now we have side angle. We don't have more than one angle. So that should be a very clear alert saying, hey, this is the ambiguous case, which means that I'm going to work sine so that I can see the angles, make sure that the angles, are appropriate, they work. So we're just going to start off. We're going to start off with A first, because first of all, I don't have angle B and I don't have side B. So I can't start off with angle B anyways. So the formula we're going to use is sine of angle A over little a is equal to sine of angle C over little c. So let's plug our values in. So we still don't know what sine of angle A is, but we do know little a is 2. Sine of angle C, so that's sine of 50 degrees over little c, which is 1. We're going to cross multiply, and I get 1 times sine of angle A, which is sine of angle A, is equal to 2 times sine of angle 50. Now, before I do this problem, because ultimately I want to know, we're going to get angle A by itself. And when we get angle A by itself, this is going to be arc sine of this value, meaning 2 times whatever sine of angle 50 is. But before I do arc sine of that, I want to know, still not working. I want to know what that is, 2 times sine of 50. So on my calculator, I want you to go sine of 50 degrees, and then I want you to multiply by 2. And you get 1.53. So what this is saying is angle A is approximately arc sine of 1.53. Now, this is saying, where is sine 1.53? Now, what you need to remember is that 1.53 is outside of our range for sine. Remember, a sine wave looks like this, right? And so what's happening here is that your range for sine is -1 to 1. And they're asking you, where is sine 1.53? So where is it up here? Well, it's not ever going to be up there. So this right here actually is no solution. It doesn't exist. So this is why we have a no solution answer. is because the angle that they're trying to make us find where sine is doesn't exist. It's outside of the range. So no solution. That's ambiguous. That's example 1 for our ambiguous case. Okay. Example 2 is a 1 solution. And so we're going to go through that. Let me draw my triangle again. So new triangle. So we have triangle A, we have B, and vertices A, B, and C. We have angle A is 40 degrees. We have little a is 3. We have little b is 2. And that's, again, we have side angle, okay? Alert, it's ambiguous. Okay, so that means that, again, I have to use angle A and sine of A. I don't have angle C, and I don't have the side C, so I cannot use side C to start with. So what we're going to do for this problem is we're going to go sine of angle A over little a is equal to sine of angle B over little b. I'm going to cross multiply once I plug my values in. So I'm going to say sine of 40 degrees over 3 is equal to sine of angle B, which is what we're solving for, over little b, which is 2. I'm going to cross multiply. I get 3 times sine of angle B is equal to 2 times sine of angle 40. All right? And then I get sine of angle B is equal to 2 times sine of angle 40 all over 3. And this is the place right now that you need to actually stop. And you need to say, make sure, just like we did in the last problem, before I take this sine and move it over to the other side so it's arc sine, you need to make sure that this actually works. Because there's no sense in working through the whole problem when it doesn't work or the value is outside of our range. All right, so let me get the value. So I'm going to go sine of 40 degrees. So I'm going to go control. Possibly I can get this to work again. I'm hoping. Oh, look at that. Okay, so I have no idea why it's working, but I'm just going to try it again. So we've got, that didn't work. Let's see. So we're going to go sine of angle, okay. I know this is going to work. We just have to give it a second. Okay. Trig, sine, 40 degrees, right on. Okay, we get sine of angle 40 is that. I'm going to multiply by 2, and I'm going to get that. And now I'm going to divide by 3. And what I end up getting is about 0.4285. So here, what this tells me is that sine of angle, so I'm going to just jump ahead to this next step, that tells me that angle B is equal to arc sine of 0.4285. And definitely round up if it needs to be rounded up. Does it need to be rounded up? No, not in this case. So now, before you find the angle, what I want to know is I want you to go back to this picture, and this is going to serve you very well if you actually draw this for every time you are trying to solve this problem. They are asking me, where is sine 0.42? Now remember, our range goes from 1 to -1. They want to know where the sine is 0.4285. So that's going to be like around here, 0.4285, right? So it's actually in 2 separate places. This is why it's the ambiguous case. So again, anytime you're using side-side angle, this is what you have to do. And so we know that it's going to be here, but it's also there. So on my calculator, I'm going to go trig, and I'm going to go arc sine, okay, maybe. Let's see. Arc sine, okay. I don't know, maybe it was too good to be true here. Let's try escaping. Let's see. Arc sine of, yeah, okay. Didn't happen again. I have no idea why that's not working. It's the first time that's ever happened. Anyway, so I'm going to go arc sine on my calculator, 0.4285. I'm going to hit enter, and I get 25.4. I'm going to round to the nearest tenths. So when doing this, I ended up getting angle B is equal to 25.4 degrees. Okay, so that tells me that this value is 25.4 degrees. And what I just found was this right here, okay? That angle. Now, because it's ambiguous, what has happened is I don't know if I'm talking about this angle or this angle right here. So in order to find this angle also, which works, I'm going to take 180, because remember, this is 360, this is 180, and if I'm just trying to find this point, if this is 25 degrees, so is this. So I'm going to take 180, and I'm going to subtract 25.4, and I get 154.6. So this angle is 154.6. So I went 180 minus 25.4. What that means to you is that you need to draw another triangle. That's exactly the same as the first one. Here's A, here's B, here's C. You had 2, you had 3, and you were also given this is 40 degrees. But instead of it being 25 like this one is 154.6 degrees. All right. Now, what's happened is this particular problem, all right, this one is only going to have one solution, even though it does look like I have two triangles. But think about this. What's the measure of angle C? So the measure of angle C for the first triangle is, let's see, 180. Remember, some of the triangles angles add up to be 180. So it's going to be 180, subtract 40, subtract 25.4, and I end up getting 114.6. So this angle right here is 114.6 degrees. That's one. All right? But in this triangle, if I go 180 and I subtract 154.16, and then I subtract 40 degrees, I'm at a negative 14, which tells me that this triangle does not exist. Because you can't have a negative value for an angle, which eliminates this option as being a triangle, and therefore this one is the only one that exists. So the only thing left for me to do now is I've got angle A, angle B, angle C. I actually just need baby c, little c. So we're going to go sine of angle C, so sine of 114.6 over little c is equal to, and pick either one, I'm going to use A, so I'm going to go sine of 40 degrees over little 3. Cross multiply, I get c times sine of 40 degrees is equal to 3 times sine of 114.6. And so little c is equal to 3 times sine of 114.6 divided by, parentheses, sine of 40 degrees. Okay, so on your calculator, try that out. And yeah. I don't know. That's just not working. So I'll try this one more time on that. We'll see if we can get it to work. Who knows? All right. Meanwhile, I'm going to print this. I'm going to try to work this one out, and I'm going to go sine of 114. So I'm going to go sine of 114.6. We'll see if this works. Calculator, trig, let's see, sine, holy cow, 114.6 equals, I'm going to multiply that by 3, get an answer, and then I'm going to divide that answer by sine of 40. So I'm going to go back to trig, I'm going to go sine of 40 degrees. I think I would have rather had a parenthesis there, but okay, I end up getting 4.2. So this value is approximately 4.2 what's that, 4.24, so 4.24. Since we're rounding our sides to the nearest hundredth, make a little box and make sure you put all your values in, right? So you're going to put the measure of angle C, which is about 114.6. We also found the measure of angle B, and that was about 25.4 degrees. These are both degrees. And then we found, what did we find? Little c. The measure of little c is approximately 4.24. Okay, let's do another one. Now, this one, this is the answer. This one is going to actually have two solutions, which is guaranteeing that I have two triangles. So let's try this. We're going to draw our triangle. And in drawing our triangle, again, I have A, I have B, I have C. And A is 35, and I've got little b, which is opposite angle B, which is 8, and I have little a, which is 6. So again, this is side-side angle. You have to identify what triangle it is. So it is a side-side angle triangle. We're going to say sine of angle A, which is sine of 35, over little 6. And we can't use C because I don't have either one, is equal to the sine of angle B, which is what we're going to find, over 8. I'm going to cross multiply. I get 6 times sine of angle B is equal to 8 times sine of 35 degrees. I'm solving for sine of B, or B, so my first step is sine of angle B equals 8 times sine of 35, and then I'm going to divide that by 6. So we'll come over to the temperamental calculator, and let's see if this actually works. I'm going to type in trig. Okay. Yeah, I don't know. I don't know what to say. It's just, maybe I'll try it one more time. There we go. And let's not do that right now. Sorry. Sine of 35. Okay, and enter. And I'm going to multiply by 8 and enter. And then I'm going to divide by 6 and enter. So I get 0.7648. So what that tells me is this. So I've got sine of angle B is about 0.7648. Okay, so definitely within our range, right, of 1 and -1. But in order to find B, I'm going to have to go arc sine. So I'm going to say arc sine of, move this sine over to the other side. You're taking the inverse of 0.7648. And so do that, and in doing that, I'm going to go arc sine. Yeah, I'm not going to do that, I guess. Let's see. Try that again. Trig, arc sine, and yeah, not sure what's going on here. Arc sine of 0.7. Actually, I don't want to even write that. What I want to do is just type in what I had from the answer right here, right? So I'm going to go control answer, and that should type that in. So where is sine 0.7647? See how it took all those numbers? We want that. It'll be more specific. So it's about 49.9 degrees. So that means angle B is about 49.9 degrees. Okay. So what I'm really asking though, and now we know that this is 49.9, okay, no problem. But again, I want you to draw this, because as you draw this, right, it gives you sort of like a visual. We know this is 1, we know this is -1. This spot right here. This is where you should be asking yourself, where is sine 0.76? Well, it's going to be a little bit closer to 1. For sure, it's up here, but also here. And so I need to know where those values are. Now, the first one we know is 49.9 degrees. To get the second one, I'm going to go 180 minus, because this distance is 49, so minus 49.9. So 180. All right, so 180 minus 49.9 is going to give me 130.1. So this other angle right here is 130.1. Okay? And so why is that important? Because I have a whole nother triangle. And I mean, I'm not drawing it to scale for sure because I would make it obtuse. But little a, we still have 35 degrees here and 6. We still have 8 here. But in our new triangle, this angle is 130.1 degrees. What that means is that I have another C I have to find. I still have this C to find. And I have both of these angles to find. Because in this problem, I have two solutions. Because think about 130.1 plus 35 degrees is 165. If I subtract that from 180, I get 14.9, which basically is telling me that this angle in here is 14.9 degrees. That works. You can have a triangle like that. The other one on the top, you're going to take 180, you're going to subtract 49.9, and then you're going to subtract 35, and you get 95.1. So this angle in here is 95.1 degrees. Also works. So in this specific problem, I'm going to have two separate triangles. I'm going to have a triangle that has my answers for the blue triangle up here. That's going to be in this box. And then I'm going to have an answer in the red box that's going to have the answers from this triangle. Meaning, what new values did I pick? I found the measure of angle B is about 130.1. I found the measure of angle C is about 14.9 degrees. And I'm also going to have little c. In the top triangle, I have new values. I have the measure of angle B is about 49.9. I have new value, the measure of angle C is about 95.1. But I also have C in the top, and I also have C on the bottom. So I have to do work for both of those. Just one more step for both, but it is another step. All right, so to find this C on the top, I'm going to go sine of 95.1 over little c is equal to, and then choose whichever ones you want. I'm going to use ones that they gave us. So 35 over 6. The other one for this triangle, the red one, that's going to be, I'm going to use sine of 14.9 degrees over little c also equals to the sine of 35 over 6. And so cross multiply on both of those. So on the left side, I'm going to multiply, I'm going to go 6 times sine of 95. So sine of 95, put a decimal, actually that's 0.1 anyways. So 0.1 equals, and divide by sine of 35. So divide by parenthesis sine of 35, and I get for that one 10.42. So C is about 10.42. And so this is the blue triangle, so this is going to be 10.42. In the right side, you're going to go C times sine of 35, and that equals 6 times sine of 14.9. And so I'm going to do that. I'm going to go sine of 14.9 times 6 divided by sine of 35. So please use parentheses, trig sine of 35. And I get 2.68, so 2.69. So this one is C is about 2.69. And we're done. So that was a lot. I mean, you just have to know what to look for. And just to review, you can use law of sines with two angles and a side. Because think about it. If you have two angles, you automatically have the third angle. Okay? So two angles and a side, you're going to use the ambiguous case if you have two sides and an angle. Okay? So I hope this helped you. I know this isn't everybody's homework, but I hope this helped you, and thanks so much for watching. All right.